Hello, welcome to Econometrics Melody. In this video, we will see some important property of the mean. And we have a random variable and it takes some countable numbers, age its valued. So let us say from 1 to let's say 9 or 10. These are the numbers and we have its respective probability over here. And the sum of the probability is equals to 1. We need to calculate the expected value of this random variable and we want to name this random variable by the name x. So expected value of x, so this is the case of discrete random variable. So we take the sum of the product of its probability and the particular observation and we sum it from 1 to n. Now let us say we have a random variable called y. We want to find the best predictor for this random variable y. And let us see it by the help of certain derivations. So we have a random variable y and let's say k is going to predict or represent this random variable y, and we want to calculate its deviation and we want to take the sum of its square. And let us see what happens. And let us also assume that the expected value of y is equal to y bar, or we can simply write it as mu. Let us write it as mu. And this can be for the expanded age y minus, let us add and subtract mu. This is going to cancel out, so ultimately their net effect is not affected. Let us consider this y minus mu is a and then u minus k is b. So let me, for our convenience, let me write it as ap, and let us use this formula: a plus b whole square. This is equal to a square plus twice a and then u minus k, sorry, mu minus k, and then plus b square, it is mu minus k and its whole square. Now let us operate the expectation. This is equal to y minus mu square plus twice, and this u, this is also constant, k is also constant, so we can take it outside the expectation and we simply get the expectation of y minus mu, and then plus again expectation of u minus k. They are also constant and there is square, so this is equal to expectation of y minus u square plus mu minus k. And if we use this property, if we take the expectation of their individual part, then we get this result, plus this is constant, both u and k are constant, so this is equivalent to u minus k square. And we know that the expectation of the constant is the constant itself. The expectation of y, we have assumed it expectation of y to be equal to mu, and expectation mu is mu itself, so mu minus mu, this will cancel out, and this is some constant. As this is 0, this entire product will be 0, so we are excluding that part, plus, and we are left with mu minus k square. Both of them are some constant, so their difference will also be some constant and their square is going to be positive. According to this relationship, we see that expectation of y minus k square, this is actually greater than or at least equal to expectation of y minus mu square. So if the value of k is equals to mu, the left hand side is equal to the right hand side. So from this relationship, we can say that it is always the mean of the random variable that is going to best represent that random variable. So in conclusion, we say that the expected value or mean minimizes the mean square error. So the expected value of a random variable, it best represents that random variable. This is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.